let's say you were faced with this non-homogeneous linear differential equation. So here the L could be anything like ax prime prime plus bx prime plus cx. That could be the left-hand side here, anything like that. And you know, last time in the last video we were looking at specifically this, where the right-hand side was te to the 3t, and there was a particular set of guesses that worked. We plugged in te to the 3t, then e to the 3t, and we saw that linear combinations of those two had hope of working as a way of giving us what we wanted out. Now suppose in this situation what we want out is 3 sine 5t, just as another example. And the left-hand side could be anything, really. Then what would be good things to put in? What would be good things to try? So the first thought would be try sine of 5t. You might think I'll try sine of t, right? But what's going to happen if you try sine of t? When you apply the derivatives to that and you multiply by a, b, and c and add, you're going to get a linear combination of sine of t and cosine of t, right? You could try it and you'll get a linear combination of sine of t and cosine of t. Like sine of t will show up here. Once two derivatives are taken, another sine of t will show up with some constants out in front. And the derivative is going to give you a cosine of t, but that's not going to help you at all because you're trying to get sine of 5t out, right? So that is a bad guess. You should guess sine of 5t and plug that in. Then what will happen? You'll get a linear combination, some stuff times sine of 5t, which is what you want 3 sine of 5t to come out, but you'll get some stuff, probably not 3, times sine of 5t, and then you also annoyingly get stuff times cosine of 5t. That's what would happen. We know that because that's, when you take a derivative of sine, you get cosine. When you take another derivative, then you go back to sine, but times some constants each time. So when you do this, you'll get a linear combination like this. If you apply the same logic that we applied last time, another good thing to try is cosine 5t. Then you'll get another linear combination of sine and cosine 5t. Then this information will give you a way of thinking about linear combinations like this, with undetermined coefficients a and b, and you'll try to see what way of combining sine 5t and cosine 5t, which will amount to linear combination of this expression here and this expression here, what concoction, a times this plus b times this, will give you out what you want, exactly 3 sine 5t. So in the case of this right-hand side, it turns out some good guesses are sine 5t, cosine 5t. This is the thing to plug in here. This is the expression whose undetermined coefficients you will try to determine when you apply this method. You see, the trouble with this method is you need to sort of get creative each time you have a new function on the right-hand side. So we did one particular thing, where'd it go? We did one particular thing back here when our right-hand side was te to the 3t. We made one particular form of guess, this, and a totally other thing here seems to be appropriate when the right-hand side is 3 sine 5t. So it seems to require some creativity each time, depending on what the right-hand side is. Now I'm going to suggest for you a way to not have to be so creative each time, which is in your textbook, this section, which I hope you will read, because that's a good supplement to the lecture, on the method of undetermined coefficients, gives you this nice table which tells you what to guess. So have this table on hand when you're doing these kinds of problems. So what they're referring to as source function here, f of t, is that right-hand side. So like here, the source function is 3 sine 5t. Back here, the source function was te to the 3t. So for example, the 3 sine 5t, this one, 3 sine 5t, that's a source function like this one. alpha sine omega t, where my omega was 5. Then it's telling you what to guess. It's saying guess something times sine 5t, my omega is 5, plus something times cosine 5t. So the omega here is the same as the omega here. If the right-hand side is alpha, what does that mean? That means if it was like just 3, you know, just a number. Then the suggestion is just guess a constant. Maybe you can find a constant particular solution. If you have an exponential, then guess an exponential with the same rate. So this beta is the same as the beta here. If you have a polynomial of degree n, then guess a polynomial of degree n. So leave the coefficients undetermined. So let me make clear what is meant by that. If you have, like, I don't know, x prime prime plus 6x, just like the example we did before, but equals like t cubed, that's a polynomial of degree 3. Then what you would want to guess is a polynomial of degree 3, but an arbitrary one. So like this, allowing possibly lower degree terms. So if you were to play around sort of the way we did back here when we were just sort of plugging in things and seeing what ingredients came out, then we would eventually come to the same conclusion, that a good guess for this is linear combination of these 4 things, 4 ingredients rather than just 2, t cubed, t squared, t, and 1. But if you want to skip to this part, which is perfectly reasonable, then this table suggests to you what to do. Oh, and notice that certain things are not in the table. Like, for example, where is it? This one, te to the 3t. That's not actually any one of the things that shows up in this table. But I just noticed this mentioned here in example 216, or at least something similar. Te to the minus 3t shows up here. And they're saying guess exponential times a polynomial of the same degree. So like if you have t cubed e to the 3t, then you would guess arbitrary degree 3 polynomial times e to the 3t. Okay, so you'll get the hang of this as you start doing it.